Test 2, woo! Almost done with unit number 2. And so now you're going to practice. Remember you don't have to do all of these problems, do the ones that you need. Same thing with this video, flip through, fast forward, rewind, whatever you need to do in order to go to the place that I answer the questions that you need me to answer. Hopefully this helps, and as always, if it doesn't, come in, ask me questions, seek help in the mornings, or I can maybe work out something during lunch after school. We'll work out a time to get together, or send me your questions on Remind of any problems that you're working on, and hopefully I can help you figure stuff out. So, okay, so for this is test 2. And it says picture to the right is the graph of the first derivative f prime. So I'm gonna write that really big. This is f prime. And it's of a polynomial function, meaning everything is continuous, the function's like nothing crazy is going on. And I know that f of 3 is -1, and that's from the original function. This is saying perform an analysis, meaning make a table and determine the intervals in which f of x is increasing and decreasing in relative extrema. So what I'm gonna do here is I'm gonna say x, and this is f prime. And what I do every time I make a table is I figure out where is the first derivative equal to 0. And I can see that happens at -2. And this does say a polynomial function, so I know that this is gonna happen and it's gonna go on forever and ever. So if this is a polynomial and I can see that I have a 0 at -2, at 1, and at 2. So I'm gonna go from -infinity to -2. And at -2, I know f prime is 0. Then from -2, so the next place where there's a 0 on the graph is at 1. And then I'm gonna go from 1 to 2, because I know the next place there's 0 on the graph is 2, and I should have thought this, but you know, you're smart, so you'll figure this out. This is 2 to infinity. Okay, so I didn't give myself quite enough room, but I know this is f prime, this is 2 to infinity. Then I see, is the derivative positive or negative? So if I'm looking from -infinity to -2, so in this range, I can see all of these values down here for f prime, do that. F prime are negative because they're below the x-axis. Above the x-axis is positive. So I'm gonna say this, -2 to 1, -2 to 1 is positive, 1 to 2 is negative because below the x-axis again, and then positive. That means f of x is decreasing on the interval from -infinity to -2, increasing from -2 to 1, and then decreasing 1 to 2, increasing again 2 to infinity. Because if f prime is negative, that means the function is decreasing. If f prime is positive, that means the function is increasing. Decreasing and increasing, and I always draw this to make sure I didn't mess up. So decreasing and increasing, or a slope that's negative to positive, means that f of x has a relative min. Increasing, decreasing, relative max. Decreasing and increasing, relative min. So when you're writing this out, you would say f of x is decreasing on the interval from -infinity to -2, and then 1 to 2, and you would give the reason as f prime of x is negative. The same, similarly for positive, except you would say f prime is positive, therefore f of x is increasing, and you would give the interval. And relative mins and relative maxes, and make sure that you're saying that f prime is changing from negative to positive, or f of x is changing from decreasing to increasing for relative mins. For relative maxes, the derivative, f prime, is changing from positive to negative, or you could say the function is changing from increasing to decreasing. In this one, -2, 1, and 2, x equals each of those values, f of x would have horizontal tangents, but we can say specifically mins and maxes, so we give more information if we can. Then number 2. Okay, so picture to the right is f of x. So this is going to be different, so we're not looking at positive and negative anymore. If I want to know if f prime of x is positive, I need to think, okay, so the slope is positive. That means f of x is increasing. If f prime of x is less than 0, that means f of x is decreasing. if f prime of x is equal to 0, that means the slope of the tangent is equal to 0. That means f of x is neither increasing or decreasing. So I would say has a horizontal tangent. Or you can say has relative extrema, because if it's neither increasing or decreasing, it could be at the top for a moment or at the bottom of the moment. So that'd be like here. And I'm gonna say this is x equals, we would be more specific, but you can see it's not quite at -2. So I'm gonna say -2.1, x equals 0 right here, and x equals 2.1. If this were on a test or quiz, it's always more specific of what those values are. There's some way to find out the exact values and you never have to guess. Okay, so increasing, I'm gonna look for the places on the graph where f of x is increasing. And I can see that happens since I use -2.1, I'm gonna do that here. -2.1 to 0, so this is on the interval, and then 2.1 to infinity. Decreasing, this one says a polynomial function, and I should have done this at the beginning, but put arrows on yours. Again, this would be clear. There would either be arrows and say that we're talking about the interval. Bless you, my husband just sneezed. This is on the interval from -infinity to infinity. Or there would be something that's saying where this started. So it would be on a closed interval, and it would say from -3.5 to +3.5 or something like that. Okay, f prime of x is less than 0, so that's happening here. So I'm going to say from -infinity to -2.1, and then again from 0 to 2.1. So very different depending on what you're looking at, so be really sure that you know this is f prime, this is f of x. Be careful about that in the beginning. Label in really big letters so you know what that means. Okay, here we've got consider this function. F of x is equal to x squared minus 2x cubed. Perform an analysis on all values. So I'm doing the same thing of making a table. So I'm saying f prime of x, and then I take the derivative, 2x minus 6x squared, set it equal to 0. So if I do that, I can factor out a 2x, and I get x, oh wait, what am I saying? And I get 1 minus 3x. 2x equal to 0 would just be x is equal to 0. 1 minus 3x equal to 0. I could add 3x on both sides, and I get 1/3 is equal to x. So when you're doing a sign analysis, because this says -infinity to infinity, I would use x, f prime of x, and I'm going to go from -infinity to my first value, where f prime of x is equal to 0, so it's 0. And then I go 0 to 1/3, because at 1/3 f prime of x is 0, and then I do 1/3 to infinity. There are shorter ways to make this table, but I want to be really sure that you know what you're doing. Sorry, can you hear Ian laughing? He's pretty happy. Not really about this calculus, more so because he's watching. Oh, now he's singing happy birthday. I don't know if you can hear him. It's no one's birthday today. He just really likes that song. Okay, -infinity to 0. I'm going to go back in, and I can put it in this part of f prime. Sometimes I like it in the factored form because I set f prime equal to 0, but this still, I know f prime is equal to 2x, 1 minus 3x. So if I put a number from -infinity to 0, and you can pick your favorite, like -5 billion, sure. 2 times -5 billion is going to be negative. 1 minus 3 times negative. So here I would have a negative times a negative, which would be a positive. So here, negative times a positive, and I know I get, on the interval from -infinity to 0, get negative. Which means f of x is decreasing. 0 to 1/3. Okay, so I have to think about this. A fraction smaller than that, maybe 1/4. So if I have 1/4, 2 times 1/4 is positive. 3 minus, I actually have to write this down, 1 minus 3 times 1/4, be 1 minus 3/4, so 1 minus 0.75, which would still be positive. So to have positive times positive, get positive. I know it could be tempting to automatically write negative here, but don't. Make sure that you're actually trying this. So I'm gonna pick 100. 2 times 100 would be positive. Negative 3 times 100 would be negative. This whole thing would be negative. Positive times negative is negative. Notice I'm putting it back into f prime and not into f of x. So that means f of x is decreasing. And then I have to figure out where our mins and maxes. So decreasing and increasing, this would be a relative min. Increasing to decreasing would be a relative max. And then you start your analysis, which means that you just write all these things out. So I would say f is decreasing on the interval from negative infinity to 0 as f prime is negative. And you could do the same thing for 1/3 to infinity. Do f of x is increasing from 0 to 1/3 on the interval, or on the interval from 0 to 1/3 is f prime is positive. Relative mins, you have to say that f prime changes from negative to positive at x equals 0, or you could say f of x changes from decreasing to increasing, since you already showed all that. At 1/3, same thing, x equals 1/3 is a relative max for the graph of f of x, and the reason is because the function changes from increasing to decreasing, or you can say f prime changes from positive to negative. Any of those are fine. If I keep going, number 4, in which I want to, because who would want to stop calculus? We've got this derivative. Caleb laughed about that. That's not funny. Okay, so f prime of x is x squared minus 4. F of 3 is 7. I got some information. And it says approximate the value using the equation of the tangent line. Sometimes it will say a tangent line approximation. Sometimes it will say approximate using the equation of the tangent line, but you need an equation of the tangent line. And everybody knows what you need for the equation of a tangent line. Well, I'm not sure if Caleb knows that. Caleb, do you know what you need for the equation of a tangent line? He shook his head no. You need a slope and a point. He's gonna get that.
A slope and a point.
A slope?
I don't get that. Just keep teaching.
He wants me to keep teaching you instead. Because Caleb...
I'm gonna show my face later. Don't worry.
He's gonna show his face later. That's what he said. Okay, so I'm using the equation of a tangent line. So I'm gonna say y minus y1 is equal to x, or is equal to m times x minus x1. So in this problem, we've got y minus, and I can see my y1 value is 7, is equal to m. M is their slope. The slope of the tangent line, when I say slope of the tangent line, you think derivative. So f prime of 3 would be 3 squared minus 4. I don't have to take the derivative because it's already given. So 3 squared minus 4, I'll get 9 minus 4, which is 5. My x1 value is 3. And then this says approximate the value of f 2.9. So I'm going to find, this is 7. And so I'm going to say y minus 7 is equal to 5. This would be negative 0.1. Which would be y minus 7 is equal to negative 0.5. If I add 7 to both sides, that would be 7 minus 0.5 at 6.5. So this I'm approximating using the equation of the tangent line. So before you can approximate using the equation of a tangent line, you must find it. A lot of times people forget that step. Don't be that person that forgets that step. You need a slope and a point, write the equation of the tangent line first. This is just a good reminder. In number 5, when you are asked to find the slope of the tangent line for a particular value of x, what are you being asked to calculate? The slope of the tangent line is the same thing as f prime of x. It's the same thing as the derivative at x. Or if this is saying in a particular value of x, sometimes we'll say f prime of a, just so you know its point. The formal definition, there's actually 2. One of them is this. So the limit is h approaches 0, f of x plus h minus f of x over h. We did a lesson, remember, if I take away the limit as h approaches 0, this is the slope of the secant line. If you, as soon as you say the limit as h approaches 0, then you're finding the slope of a tangent line. So here, if you're ever given something in this form, you can always just figure out what is the function and then take that derivative to find f prime of x. The other thing is we have the limit as x approaches a. And if I'm thinking y2 minus y1, so f of x minus f of a over x minus a, this is also the derivative, but it's at a particular place in a. So I'm gonna say f prime of a. So if I'm asked to find the derivative, so like if you're given something in this form, but the question's given to me in limits, so either one of these, can I do it the easy way and just do the power rule or trig derivatives? So like the derivative of sine is cosine, the derivative of cosine is negative sine. Do this the easy way. I only wanted you to write it down for the first few problems. I think there were about 5. There's 1 or 2 throughout that we couldn't put in a form of a polynomial, but anytime you can do it the easy way, yeah, it'll make your life easier and less chance of mistakes, and you have more time for other stuff, like more calculus. Woo! So in the next one, this is on 8. It says find f prime of x. If you need practice, find the relative min and max of each. So in this, if you want to make a table on each one of these, feel free, go through that whole process. I'm just giving you extra problems to do that, and if you have any specific questions, let me know. But I'm just gonna help you find the derivative of each one, and then you can go further if needed. In this first one, it's already set up nicely for us. So I'm just gonna take the exponent. I've got an exponent of 3 times 3, and I get 9x. Make sure you take the exponent and subtract 1. The derivative of 4x is just 4. In the next one, oh, I shouldn't have done this yet. I have f prime of x, but this isn't quite nice, so I'm gonna rewrite this, f of x. Instead of 3 square root of x, I'm gonna write it as 3x to the 1/2 power minus 7x squared. So when I take the derivative, I can take 1/2 times 3, which would be 3/2 x. Make sure you still subtract a 1 whole from the exponent. So 1/2 minus 1 whole will be 1/2 minus 2 over 2, negative 1/2. This would be 14x. And then rewrite this so there's not an negative exponent. So I'm gonna rewrite this as 3 to x to the 1/2 power, because it started out as a negative exponent, so I can put this in the denominator, minus 14x. If you wanted to write this as the square root of x, it wouldn't be the square root of 2x, it would just be the square root of x, because that's what had the negative exponent. If there were some parentheses, then 3 over 2 would also be negative 1/2, but there's not, it's just x. These kind, you can take x to the 4th and divide it by x to the 3rd, and 2x to the 3rd divided by x to the 3rd, and 5x divided by x to the 3rd. Because then you can say, okay, well, you know what? This is still f of x, but x to the 4th over x to the 3rd is the same thing as x to the 1st. This x to the 3rd and x to the 3rd totally cancel out, so you'd have just 2. Plus here, 5x over x to the 3rd would become 5x to the negative 2nd power. You've done all this work, but don't think that you're done, because I knew this was all f of x. F prime of x then would be the derivative of x is just 1. Negative 2 times 5 is negative 10. And then I've got x, this would be to the negative 3rd power. If I rewrite this, I would get the derivative of 1 is 0. Negative 3 times 1, negative 1 is still 3. Well, positive, sorry. I was saying negative 1, but this is a 10 here. Wait, what am I doing with my life? Oh my goodness, I almost took the derivative again. Do you see what's happening? So this was my function. This was my derivative. I'm gonna get it together. I was distracted by Moana songs, but no more. I've got this, everybody. All we're doing is rewriting this. So 1 minus 10 over x to the 3rd power. Whew, we did it, pulled it together. And just because this is good fun, if I wanted to write this as a single fraction, the way that I would do that is that I would make sure that I could multiply that 1 by, sorry, I was getting another marker, by something so that it would have a common denominator of x over 3. But I can't just do that without multiplying the numerator. So I could say that this derivative is x to the 3rd minus 10 over x to the 3rd also. just another way to write it, just so you're aware that this is actually a thing that you can do if there's different answers. Okay, in the next one, x to the third, and this is square root of x is the same thing as x to the 1/2. So just like in the last one, I could divide each part by what was in the denominator. I can do that here too. So I'm gonna say x to the 1/2, x to the 1/2. And then I get, if I subtract these exponents, I would have 3 minus 1/2, which would be x to the 5/2 plus 4x. This started out as 1. 1 minus 1/2 would still be 1/2. Now I can take the derivative. Well, I'm running out of room and my dog is shaking his ears. Okay, so I have 5/2 x. I'm gonna subtract 5/2 minus 1 would be 3/2 power. 1/2 times 4 is 2x, and then I subtract 1 from the exponent, so I get negative 1/2. If I rewrite that, it would be 5 over 2, x to the 3/2, that all stays the same. But here I'd have 2 over x to the 1/2 power. And again, this is the derivative. This one, I'm running out of room, but that's okay, because this one actually is an easier derivative, even though it looks gross. The derivative of theta is just 1. Think about this, if theta messes you up and you want to put 0 or something else, think about it in terms of x. Like if I had the function y equals 1x plus 0, the slope of that line is 1. So here, the slope of this line is still 1, even though we're talking about theta instead of x. The derivative of sine is cosine, and this coefficient stays here. And this one, again, it's rewriting, so I have 5x. This would be x to the 1/3 power. Oh, I would maybe go back and do relative mins and maxes of one like e, just because we didn't do a ton of those, and I know some people struggle with trig values. So if you know that that's one of your weaknesses, go back and try to figure out what are the mins and maxes of this function. So this would be 5x, 1 minus 1/3 is 2/3. If I take the derivative of that, I get 2/3 times 5, which is 10/3 x. 2/3 minus 1 whole is negative 1/3, which would be 10 over x to the 1/3 power. Okay, last one. This is the same thing. If you say to the 1/3 power, that's the same thing as saying take the cubed root of a function. Okay, so for any function and given a 9, how do you find the slope of the tangent line at x equals 2? You substitute. Once you get f prime of x, substitute in 2. If you want the slope of the line perpendicular to that, you have to find the slope of the tangent line and then take the opposite reciprocal. Almost done. We're on the last 2 questions. In this one, it says the table of values represents, or what does this say? Represents values of the graph of the derivative, h prime of x. So this is h prime of x right here. We've already got the derivative. So when you make those tables, you've already done the hard work. Here, this is done for you. The zeros indicated are the only zeros on the graph. That's nice. So when we take the derivative, when we set it equal to 0, we're doing that so we can find these intervals. That I go from negative infinity to negative 2, then we stop at negative 2, and then we go negative 2 until the next 0, which is 7. And then 7 to infinity. You guys are getting some good background music in this, because I'm pretty sure that's just Moana right now, because my son's playing with the toy. Okay, from negative infinity to negative 2. So after you find the zeros, you try to pick a value between negative infinity and negative 2. There's already 2 chosen for you, and I can see in both of those that h prime of x is positive, and they'll always be the same. If the sign is changing, that means you did something wrong, and go back and look at it. From negative 2 to 7, I can see all these values of the derivative are negative. 7 to infinity, negative again. If I want to know h of x is increasing, I know that is when h prime is positive. And I can see right now that that only happens on this interval from negative infinity to negative 2. H of x is decreasing when h prime of x is less than 0, and that only happens from negative 2 to 7. and 7 to infinity. And you have to stop there because at 7 the derivative is 0. I'm running out of room. But relative minimums happen when the derivative is changing from negative to positive. And right here, positive to negative, I can see there's going to be a max. Negative to negative would be like negative to negative. So there's no horizontal tangent here, but it is not going to be a relative min. So if you get something like this, which you might, you would say h of x does not have a relative min as h prime does not change from negative to positive. If you're doing maximum, you would have to say h prime of x does change from positive to negative at x equals negative 2. So x equals negative 2 is a relative max because h prime of x changes from positive to negative. Okay, last question. If I want to know what the tangent line approximation is, and this is where people mess up again, because they're like, I don't know, I pick some value close to 5 and I do something. If you want the tangent line approximation, you must have a tangent line first. Right now, I have a point, so I know I need a slope. Slope of the tangent line is the derivative. And you're like, where do I get this from? This is h prime. 5 is right here. My slope is negative 1. So you're going to say y minus y1, which comes from over here, is equal to m times x minus x1. Once you get to that point, you can substitute in 5.1. So I'm running out of room, but I can do this. Y plus 2 is equal to negative 1. 5.1 minus 5 is 0.1. If I say y plus 2 is equal to negative 0.1, and I add, or no, actually this one I'm going to subtract 2 on both sides because it's y plus 2. I would get negative 2.1 is my tangent line approximation. So it's approximately h of 5.1, which I'm hoping that's true because really close to that, h of 5 is negative 2. Okay, so you can do this long video. I'm going to do one more video with a free response practice. Caleb, do you have anything you want to say to the class?
Bye.
Do you want to tell them good luck?
Good luck.
Or you want to tell them how awesome they are?
You're awesome, whoever you are.
You are awesome. He doesn't know you, but I do, and you're awesome. So keep up the great work, and I'll see you soon.
You're my mom's student.
He knows that you're my students, and he knows that I talk about you, and I think you're great. Okay, have a great day. Study lots. Bye.